Hello secondary 1. This is part number 2 in the first lesson, heat energy. In this video you will know how can we answer the problems related to the heat energy and the quantity of heat. Okay, the quantity of heat, even it absorbed or released, is directly proportional to the difference in the temperature. If the difference in temperature increase, so the quantity of heat increase, even it is absorbed or is released. How can we calculate the quantity of heat? This is our rule to calculate the quantity of heat. QP, which means quantity of heat under a constant pressure, and its measuring unit is joule, equal mass, its measuring unit here is gram, multiply C, which is specific heat, its measuring unit is G per gram, dot or multiply Celsius degree, multiply difference in temperature, and its measuring unit is Celsius degree. Okay, the delta T, which means the change in temperature, equal T2 T final minus T1, which means T initial, to T final temperature minus initial temperature. Let's go to see different types of problems. Problem number 1, this is problem in your booklet, page 8. When using calorimeter, 0.28 gram of propanol fuel was burned. This raised the temperature of water by 21.5. The mass of water in calorimeter equal 100 gram. Find the amount of energy resulted from the burning of fuel. Find the amount of energy resulted from the burning of fuel. Pay attention, here I will use the mass of water, not the mass of propanol fuel, as I measure the difference in temperature in water. Firstly, I measure the initial temperature of water. After burning the propanol, we measure the final temperature of water and then find the change in temperature. So here I will use the mass of water. Pay attention. Firstly, you must write your rule. QP equal mass multiply specific heat multiply delta T. Here I want to calculate QP equal mass of water 100 gram multiply the specific heat of water is a constant value, and you must know it, 4.18. This is the specific heat of water. So if he asks you about the quantity of heat absorbed or released by water, you know that the specific heat of water equal 4.18. Okay? Multiply the delta T here. Here he gives you delta T directly. He doesn't give you T initial and T final. He gives you here the delta T directly. So the delta T here 21.5, and the value will be 8,987 joule as quantity of heat. Its measuring unit equal joule. Pay attention. To convert the quantity of heat from joule to calorie, you know that we must divide the value by 4.18, and to convert the quantity of heat from calorie to joule, we must multiply the value by 4.18. This is another example in your booklet, page 8. An unknown substance of mass 155 gram absorbed 5,700 joule of energy, which increases its temperature from 25 Celsius degree to 40 Celsius degree. Calculate its specific heat. Pay attention here. I have T final and T initial, the final temperature and initial temperature, so we must subtract them to calculate the change in temperature. Write your rule. QP equal mass multiply specific heat multiply delta T. To calculate the specific heat equal QP, yes, divided mass multiply delta T. So specific heat equal the value of QP, quantity of heat, 5700 divided, don't forget to put the brackets, divided 155, which is the mass of a substance, multiply 15, which is the difference in temperature, 40 minus 25. To calculate delta T, you must subtract T final minus T initial. So 40 minus 25 equal 15, and the value of specific heat here equal 2.4516, and the measuring unit of specific heat is joule per gram multiply Celsius degree. Number 3, this is in your booklet, page 9. Calculate the amount of heat released from cooling down 350 grams of mercury from 77 Celsius degree to 12 Celsius degree. The specific heat of mercury is 0.14 joule per gram Celsius degree. Firstly, you must write your rule, then substitute each one. The mass here 350 gram multiply the specific heat 0.14 multiply change in temperature. Pay attention here, I will subtract 12 minus 77, 12 minus 77, T final minus T initial, so the value will be negative 65. This is the difference in temperature, and the value of the quantity of heat equal negative 3185 joule, and this is indicate that this reaction is exothermic reaction, as the quantity of heat here in the negative value. This indicates that this reaction is exothermic reaction. Exothermic reaction means there is heat energy released by the system to the surrounding. Now I will talk about the device which is called calorimeter. Calorimeter used to measure the difference in temperature, of the chemical reaction. This is the picture of calorimeter. As you see, the component of the calorimeter: number 1, isolated vessel; number 2, thermometer to measure the initial temperature and final temperature; number 3, stirrer to stir the water, okay, and distribute the temperature all over the water; number 4, liquid, usually water. The idea of working here: firstly, at the beginning of the reaction, the thermometer measures the initial temperature of water, okay, yes, and record it. Then at the end of the chemical reaction, you will measure the temperature of the water by the thermometer, then record it. Then you can calculate easily the difference in temperature, which is T final minus T initial. I have another type of calorimeter, which is combustion calorimeter or bomb calorimeter, which means burning calorimeter. This is the burning calorimeter. Here I have the liquid, which is water, an isolated system, a thermometer, and I have motorized stirrer motorized stereo, and I have two electric wires for burning, connecting to the substance that I want to burn it. Okay? Its function, measure the change in temperature of burning reaction or during burning a substance. The idea of operation, number one, by using the burning electric wire used to burn the substance, then we must measure firstly the initial temperature of water, then the final temperature after burning. Then you can calculate the difference in temperature, T final minus T initial. This is the end of lesson 1. Thank you and see you later in lesson 2 inshallah.